Hello again. Today we're going to be talking about simplifying algebraic expressions. Okay, so as we always do, let's start out with what we're hoping to complete by the end of the lesson, hoping to be able to do. Hopefully, I will be able to use proper mathematical terminology when discussing expressions and equations. And hopefully, you'll be able to say, I can simplify algebraic expressions by combining like terms. If you're unsure what that means, just hold on, listen closely. Alright, we need to start out with some terminology. This will go with our first I can statement. So firstly, a term. Each part of an algebraic expression is separated by a plus or minus sign. In case you're unsure what that means, we have an algebraic expression right down here. Okay? Each part of this that's separated by a plus or minus sign is a term. That means negative 6 is one term. That means 2x, and that's a positive plus sign, so positive 2x is a term. That means negative x is a term. That means positive 3 is a term. And that means 5x is a term. That means you have 5 different terms in this algebraic expression, at least initially. Each of those is a term. Secondly, we talk about the coefficient. The coefficient is the numerical part of a term that combines a variable. That contains a variable. So, that means down here in our expression, any of the parts that contain variables like 5x, okay, the coefficient is the numerical part. It's the 5. 5 is the coefficient of x here. And guess what? Over here you have an x. But it just says negative x. Really, there's a negative 1 out front. So the coefficient of this term is negative 1. And the coefficient of 2x is 2. Negative 6 and positive 3 are not coefficients. They are not the numerical part of a term that contains a variable because they don't have a variable. Okay, these guys are actually, so I'm going to circle those for you, negative 6 and positive 3 are constants. That's our fourth definition. That's just one of our terms that does not have a variable. And lastly, we have like terms. Okay, terms that contain the same variable that are also raised to the same power. So in our expression down here, fortunately, nothing has a power that's different than 1. So 5x and 2x and negative 1x are all like terms. Okay, they have the same variable. Doesn't matter what the number is in front of them. They all have the same variable, and they all have the same exponent, because really there's an imaginary 1 right above those x's, isn't there? So those are your like terms. Those are the terms that you're going to be able to combine. Please don't forget, positive 3 and negative 6 are also like terms. Okay? You're going to be able to combine those because they are similar. Now, let's bump on down to our first example here. Identify the terms, the like terms, the coefficients, and the constants in the expression. We kind of just did this. So, in case you missed what I said, I'll go through it one more time. I'm not going to write them out for you. If I were you, though, I would write them out. So, you should probably write out terms, colon, and then you should say, well, 5x is one term, 3 is one term, negative x is one term, 2x is one term, and negative 6 is another term. So I'll do the first one for you, and then I won't do the others. 5x, positive 3, negative x, 2x, and negative 6. If I were you, I would also write just below this, like terms, and then which one are the like terms? Okay, back to our definition. The terms that contain the same variable that are also raised to the same power. So your like terms are 5x, negative x, and 2x. So once again, write those right here, just below your terms. And then our coefficients. So like we said, if you forget what that is, go back up to your definition. The numerical part of a term that also contains a variable. So we only have a couple of those. Notice there's a variable here, so there must be a coefficient. That is 5. No variable with the 3. Okay, here's an x. There's a variable, so the coefficient must be 1. Well, actually, it's not just 1, it's negative 1, because there's that subtraction sign in front. And lastly, our coefficient to 2x is just 2. So maybe you want to write those right here. And then lastly, the constants, as we already said, those are just the numbers that don't have variables. So that is positive 3 and negative 6. You can list those right below there. I'm going to move on. Okay, to our examples finally. It says simplify each expression. You're able to simplify an expression by combining all of your like terms. Okay, so as long as you understand what the term like terms means, you're not going to have a problem simplifying. In A, our first example, our like terms are of course going to be 8n and 4n because they have the same variable, and that variable really they have the same exponent. It's just 1. So 8n, and of course this is a positive 4n, makes 12n. So we combine those guys. And then what do you have left over? Just a positive 4. Okay. Some might say, well, why can't I combine 12n and 4? Well, 12n and 4 can't be combined because they're not like terms. They're not. That's like saying, I have 12 apples, and I want to add to it 4 oranges. I don't have 16 apple oranges. I still have 12 apples and 4 oranges. So you keep those separate. Okay? This is as simple as you can make this expression, so you are done. Let's move on to B. So once again, if it says simplify, the first thing you want to do is identify your like terms. If you need to underline or circle, please do so. Okay, so let's start off. 6x. Are there any other x's? Yeah, there are. We've got negative 5x right here. Okay, let's also look and say, okay, we've got 4, a positive 4, and a negative 7. So you're looking at your like terms here. We've got 6x minus 5x is just 1x. And you've got, maybe I should write this out. I'm sorry, I'm doing a lot of this in my head. So I almost just rewrite it like this. 6x minus 5x. Because there's a positive 6 here and there's a negative sign in front of this 5. And then we switch over to our constants and you have a plus 4 and a minus 7. Okay, so really you're combining the red with the red and the blue with the blue. So the red's 6 minus 5 is 1x. And the blues are a positive 4 minus 7. So it's going to be minus 3. And there's your final answer. X minus 3 is as simple as you can go because you cannot combine your x and your negative 3. Alright, example number 3. We have negative y plus an entire quantity here. Okay, this should be ringing some bells because you have a number multiplied by a sum, x plus 3y. This should be taking you back to yesterday's lesson on the distributive property. Okay, so before, oops, sorry about that. So before yesterday, you had to distribute that 2 to everything on the inside of the parentheses and multiply by both those numbers. PEMDAS would tell us, if we were going to simplify this, that we have to multiply before we can add. That means before you're allowed to say negative y plus anything else, since I can multiply 2 by these numbers,